Okay, this is number, let's see, 4 on practice 4 on page 21. A 78 kilogram skydiver has a speed of 62 meters per second at an altitude of 870 meters above the ground. If 500,000 joules of energy are dissipated during the fall due to air resistance, with what speed will the skydiver hit the ground? Okay. All right. So the first thing that you're going to do is, let me get a pencil here. Okay, is make a little picture, and I kind of don't have space here. Okay, so position A is going to be the skydiver. Here's the ground. Okay, 870 meters. Okay, and then by the end, here's a skydiver, okay, at the ground level. Okay, all right. The important thing to note, okay, is position A is going to be at 870 meters. Okay, and position B, we're going to say, is at the ground. Okay, when something is at the ground, it is still moving. All right, it does not mean after it smacks into the ground. Whenever it says something like that, with what speed will they hit the ground or something like that, it means right at the ground level, but before it stops. Okay, all right, so we're going to go through and ask ourselves the questions for the first part. Okay, at the top, is the skydiver above the ground? Yes. Is he moving? Yes. Gives a speed. Any spring stretched or compressed? No. And any ED? No. Never at position A. Never, 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 never. Okay? All right, so my EG is going to be MGH. Okay, the mass is going to be 78 kilograms times 10 newtons per kilogram times 870 meters. Okay, so that's going to give me an EG of, I'm looking for a calculator, 78 times 10 times 870, a lot, 600 joules. Okay, I also know he's moving, so he's going to have a kinetic energy. Okay, it's already isolated for kinetic energy, so all I have to do is plug my numbers in. 62 meters per second squared, and I'm not going to forget to square it. Hopefully you are not either. Okay, so 62 squared, then times 78 divided by 2. Okay, 149, 916. This is 0. Uh-oh, ED is 0. I don't have space for it. Okay, sorry, it's hard to get it to fit on this stupid thing. Okay, so if I add these two together, 678, 600, I come up with a total energy of 828,516. Whoops, joules. Okay. All right. 678 of that is gravitational, which is about 80%. Okay, so I'm going to fill up most, a little more than 3/4 with EG. Okay, and then the last 20% or so is EK. All right. Same thing with my pi, about 80%, so a little more than 3/4 is EG, and then about 20% is EK. All right. Okay. What I know now is that the total energy is the same when I cross over, so this has to be 828,516. Okay, and then let's ask ourselves the questions again. Is he above the ground? No, because it says he's at the ground level. Is he moving? Yes, he has not smacked into the ground yet. Springs? No. ED? Yes, it gives that ED. Okay, and it says it's 500,000 joules is ED. Okay, all right. I know there's none of this and none of this, so I know that all that's left is going to be the EK. So if there's 828,516 total, and 500,000 have gone to the air resistance, that means that my total EK that is left is 328,516. Okay, I just subtracted those because I know the ED plus the EK has to make the total. Okay? All right, now it's asking me to find his speed, so if I write my equation, okay, again, if you can isolate it, that's great. If you can't, that's fine, just plug in the numbers. Okay, so I'm going to have 2 times this horrible number that's hard to write with this pen. Okay, divided by the mass, which was 78 kilograms. Okay, so then my V is going to be 2 times 328,516 divided by 78 is 8,400. Okay, and then if I take the square root of that, is 91.8 meters per second. So pretty fast. Okay, so there's my answer. Okay, right? So now my EK was only about, what, like a little less than a third or so of it. Okay, and then my ED was the rest of that, about 500,000. Okay, so look at like a peace sign or so. Maybe a little less than a third is about EK, and then ED is the rest. Okay.